Hello and welcome to this exploratory data analysis on coffee shop sales. In this project, we are going to analyze the transaction record of a fictitious coffee shop and provide insights into the business. So what is the project about? You have been hired as an analyst by the Maven Roasters, a fictitious coffee shop that operates out of 3 New York locations, and you have been tasked to analyze the transaction records and provide insight into the business. So in this project, we are going to analyze the transaction records of a coffee shop using Python. So here are the features of the data set that we're going to work with. So the first thing that we need to do is to import the libraries that we're going to use. So we'll start by importing Pandas as PD. Next is to import Numpy as NP. Then we'll import Matplotlib .pyplot as PLT. Next is to import our Seaborn library as SNS. Then we need to set the maximum display of our column so that we can be able to see all the columns we have in our table. So pd.set option, and what we are setting is the display dot max underscore column. We are setting it to none. Then the next thing we need to do is to import our OS, and we also import warnings so that we can be able to filter all the warnings. So warnings dot filter warnings, and we are setting it to ignore. So it's going to ignore any warnings. So these are the libraries that we're going to import. So we need to execute this statement. We can execute this statement in two ways, by either clicking on run, or we can press shift and enter key. Our statement has been executed successfully, as we can see the number indicated. So this is the first statement that we executed. We have imported our libraries. So the next thing we need to do is to import the data set that we're going to work on. Before we can import the data set, we need to know the name of the file. So we're going to list out all the files that we have in our folder. List the files in the folder, and we do that using our os.list directory. So in our folder, the name of our file is the coffee shop sales, and the extension shows that it is an Excel file. So we need to import this file, our coffee shop sale. We need to import it. So we import this file into our data frame. So we call that data frame df is equal to import our Excel file, we use the function pd.read_excel. And the next thing we need to do is to indicate the name of the file. So coffee shop sales. So that's the name of the file. So we are importing this file into our data frame called df. Okay, so let's execute this statement. We have an error, which is because we did not include the extension of this file. So we copy this extension and include it. So let's rerun this statement. So our data has been imported successfully, and our file has been imported into the data frame called df. Okay, so we are in this section called the data wrangling, which involve checking our data for quality issues. So in this section, we are going to perform data cleaning steps to ensure that our data is clean before we can use it for analysis. Okay, so the first thing we need to do is to view the first 5 rows in this table, and we do that by using the head function. So df.head. So this function will display the first 5 rows in our table. Remember, we imported our data into a data frame called df. So let's execute this statement. So here is the first 5 rows in our table. So in our table, we have the transaction ID, the transaction date, the transaction time, the transaction quantity, store ID, the store location, the product ID, unit price. We have the product category, product type, and the last column is the product details. So these are the columns that we have in our table, and here is the first 5 rows in our table. So the next thing we need to do is to check the shape of our table. So we want to know how many rows and how many columns that we have in our table. So to do that, we use the shape attribute. So df.shape. So by executing this statement, we have that in our table, we have 11 columns and 149,116 rows. So in this our table, there are 149,116 rows or records, and then we have 11 columns. Okay, so the next thing to do is to check for missing values. We want to know if this our table, if this our data set has any missing value. And to do that, we use the method df.isNA. So this method will check if there is a missing value in our table. This method returns a true or false value. So we need to include .sum to add up the true values and the false values. So this will give us the sum of all the missing values that we have in our table. So let's execute this statement. So we can see our results that in this table, there are no missing values. Each column has the value 0, indicating that there are no missing values in our table. Okay, so the next thing we need to do is to check for duplicates. So to check for duplicates, we use the method df.duplicated, and then we also add the sum so that it can sum for us the number of duplicates that we have in our table. So let's execute this statement. So the result says that we have no duplicates in this our table. Okay, the next thing we need to do is to confirm the data types that we have in our table by using the attributes df.dtypes. So this attribute will tell us the type of data that we have in each of the columns in our table. So let's execute it. So here is our result. So from our result, we can see that the transaction ID has an integer. We have the transaction date, which is a date time. We have the transaction time, which is an object. This is supposed to be a time value or a date time. We have the transaction quantity, which is an integer. We have the store ID, an integer. We have the store location, which shows that it is a string. We have the product ID, which is an integer. We have our price, the unit price, a float. We have the product category, product type, and the product details to all be a string. So we have been able to confirm the data type of the columns that we have in our table. So the next thing we need to do is to perform a summary statistics. So we need to carry out a summary statistics for our numerical variables or numerical fixtures. And to do that, we need to first select the numerical fixtures that we have in our table. So what we need to do is to assign those numerical features to a variable called numerical column. So this variable will contain the list of all the numerical columns, and we retrieve those numerical columns by using the method select dtypes. And in this method, we are including those features that contain number or integers. So this our statement is going to select the features that contain numbers and assign it to this variable called numeric column. Then to carry out the summary statistics, we use the describe method. So numeric column dot describe. So this method describe will now give us the summary statistics for the numeric columns that are being stored in this variable. So let's execute this statement. So here is our results. So meaning that in our data set, we have 5 numerical columns: the transaction ID, transaction quantity, the store ID, product ID, and unit price. And here is the summary statistics for these numerical variables or numerical features. So for our unit price, we can see that the maximum unit price is $45, while the minimum is 0.8, that's 8 cents. We can also see the mean unit of the unit price, which is about $3. And we can also check our transaction quantity. And from our transaction quantity, we have that the maximum quantity that was purchased was 8, and the minimum quantity sold is 1. So here is the summary statistics for our numerical features. So the next section is the feature engineering. So in this section, we are going to engineer new features that are essential to our analysis. And before we begin, we need to make a copy of our data set. So let's call that copy data to be equal to our data set is df, and we use the method copy to make a copy of our data set. So this statement will create a copy of our data and call it data. So let's execute this statement. Let's confirm that. So we'll preview the first 5 rows of our data, data.head. So we can see that we have the same data that we had in our data frame df. So we're going to be working with this data frame called data. So we are about to create new features. And to start, we are going to create a column called the transaction timestamp, which will combine the transaction dates and the transaction time. So let's create that column. So we have data. We are creating a new column called transaction timestamp, and the values that will be in this column will be a combination of the transaction date and the transaction time. So we have our transaction date. So first we need to convert this to a string, because the transaction date contain a date time data type. So we convert it to a string by using the as type methods. We are converting it to string, and then we are concatenating this transaction date to our transaction time. And we are also converting this column to string. So this statement will create a new column called the transaction timestamp by concatenating the transaction date and the transaction time. So we are saying in this statement that we are converting this column called transaction date to string, and we are also converting this column called the transaction time to string before we then concatenate the two of them together. So let's execute this statement. So we have been able to create a transaction timestamp. So the next step is to convert this transaction timestamp to a datetime data type. So this will give us that our transaction timestamp, so we are converting it using the toDateTime function. So pd dot to datetime, and we pass that column as an argument. So we copy it and paste it here. So this will convert the transaction timestamp to a date time. So let's execute this statement. So we have an error in our results, and we need to debug the error. So from our error, it says unknown string format. And if you look at the format, we can see that there is no space between our date. This is our date. This portion is our date, and this portion is our time. So we did not give a space between these two, the date and the time. So we need to go back to our previous statement where we created this column called the transaction timestamp. So we need to concatenate a space. So I'll add that space here and then concatenate it. So we have added a space between the transaction date and time. So we need to rerun the statement. It has been successfully executed. So we need to run this statement where we are converting the timestamp to a datetime data type. So let's rerun the statement. Okay, so the statement has been executed successfully. So let's confirm that our column transaction timestamp has been created and it has been converted to a datetime data type. So we do that using our dtype attribute. So here is our result. We can see our transaction timestamp and the data type is a datetime data type. Okay, so the next column that we're creating, we want to create a new column. This column will contain the transaction month and the transaction month name. Okay, let's add two cells. So in this cell, we are creating the transaction month. So we are going to create the transaction month in this cell. So let's call it transaction month. And to create this transaction month, we are going to extract the month from the transaction date. Okay, so that will give us our transaction date. So to extract the month, we use the .dt accessor to be able to access a date time column. So this gives us the ability to access a date time column. And to extract the month, we use the month attribute. So this statement will extract the integer of the month that we have in our transaction date column. So let's execute this statement. Okay, so the next column to create will be our transaction month name. So we want to create our transaction month name. So this column will contain the name of that month. So to do that, let's call it the transaction month name. and we're creating this column from our transaction dates, and we're using the .dt accessor, and then the function called the month name. So this function will extract the name of the month. So let's execute it. So we have been able to create additional two columns, the transaction month, which contain the integer of the month, and then the transaction month name, which contain the name of the month. The next thing we need to create is the transaction day and the transaction day name. So let's add two cells below this cell. So in the first cell, we are going to create the day of the transaction. Okay, so we call it the day of the week, and we are creating this column from our transaction date and we are using the day of week attribute. So this, we create a new column called day of week, which will return the integer for the day of the week. So let's execute it. So the next column we are creating is the day name. So we want to create the transaction day name. So we call it the day, and we're creating this column from our transaction dates by using the day name methods. So this function day name, we extract the name of the day from our transaction date and create a new column called day for us. Okay, so let's execute it. Then the next column we need to create is our transaction hour. So data, we are calling that column the transaction hour, and we are creating it from our transaction date column by extracting the hour using the hour attributes. So the next column we need to create is our revenue, which we are going to create by multiplying the transaction quantity by the unit price. So let's call that column revenue, and we're creating this column by multiplying the transaction quantity by the unit price. So this statement will create a new column called revenue by multiplying the transaction quantity by the unit price. So let's execute it. So now we want to confirm the new columns that we have created so far. So we run the head function. So here is our table, and if we go to the end, we can see the columns that we created. So we have our transaction hour, which is showing 0. So that means that we made a mistake in our transaction hour. We need to go back to our statement. So this transaction hour, we are going to extract the hour from our transaction timestamp. So let's change this statement. So we are extracting the hour of the transaction from our transaction timestamp. So let's execute this statement again, and let's confirm if it has been corrected. Okay, So we can see from our transaction timestamp that the hour here is 7, and we have it to be 7 here. So we have been able to create the transaction timestamp, transaction month, the transaction month name, the day of the week, the name of the day of the week, the transaction hour, and the revenue. So this concludes our section on feature engineering. So the next section of our analysis is the data exploration section. So in this section, we need to explore our data to have an understanding of what our data is all about. So the first thing we need to do is to check the earliest transaction dates. And to do that, we need to retrieve the minimum transaction date from our transaction timestamp. So that will give us the earliest date of transaction. So data, our transaction timestamp, and we want to retrieve the minimum date from this column. So we're using the min methods. So we can see that from our results that the earliest date of transaction was on January 1st, 2023 at 6 minutes after 7. So let's check the latest transaction dates, and we do that by using the max function. We have a transaction timestamp, and we use the max function to retrieve the maximum transaction dates. And from our results, the latest transaction date was on 30th June 2023 at 3 minutes to 9, that's 8:57. So from our earliest transaction date and latest transaction date, we can say that this our data set contain 6 months records of transaction. So we have a 6-month transaction record in this our data set. So the next thing we need to do in this data exploration is to check the unique transaction hours. So we do that by using the value count. So we count the values in our transaction hour column. So our data, we have our transaction hour, and we use that, and we use the value count method. So this value count method will return the unique values that we have in our transaction hours and count those unique values. So let's execute this statement. Okay, here is our results. We need to sort the index of our results in ascending order. So we add another method, which is sort index, and we're sorting in ascending order. So ascending is equal to 2. So this method that we just added, we sort the index in ascending order. So let's execute it. So we now have our results. We can see that the transaction hours start at 6 a.m. in the morning and stop at 8 p.m. in the evening. So the next step in our data exploration section is to check the unique transaction quantities. So to do that, we will use the value count to return the count of the unique values that we have in our transaction quantities. So we have our data, the transaction quantity, and then we are using the value counts. So here is our results. The result shows that the different quantity that we have sold include 1, 2, 3, 4, 8, and 6. So there are about 6 different units that were sold, and the majority of the units that were sold were 1 unit and 2 units. So these were the major quantity that were sold in our different stores. So the next is to find out the number of stores that we have in our data set and their location. So we start by, so let's add 2 cells below here. So in this cell, we are going to check the numbers of the stores. So to do that, we use the method nUnique to return the number of unique stores that we have. And we do that on our column called the store ID. So we use the method nUnique. So this method will return the number of unique values that we have in our store ID. So let's execute it. The result shows that we have 3 unique store IDs, which implies that we have only 3 stores. So let's find out the locations of these stores. To do that, we are going to return the unique values that we have in our store location column. We have our data, we have our store location, and then we use the method unique. So this method is different from this. This returns the number of unique values that we had in a column called the store ID. But this method will return the unique values that we have in the column called the store location. So let's execute it. So from our results, the 3 store locations are the Lower Manhattan, the Hell's Kitchen, and Astoria. So these are the 3 store locations. So the next step in our data exploration is to find out the number of unique product categories that we have. Okay, we can do that by using the nUnique methods. So we are doing that on the column called product category. So we want to return the number of unique product category that we have. From our results, there are 9 unique product categories. We can display those different categories by using the unique method. So we have our data, product category. We want to see the unique product categories we have. So we use the unique method. So this gives us the different product categories that we have. So here are the 9 different product categories we have in our data set. Okay, finally, in our data exploration, we want to find out the number of products that are being sold in our 3 stores. So we are checking the number of products being sold, and we are doing that in our column called the product type. So we use the nUnique method to return the number of unique product type that we have. So our result says that we have 29 unique product types. So in this section, we were able to explore our data and have an understanding of the data that we are working with. The next section in this our project is the data analysis. So in this section, we are going to analyze our data. And the first thing we are doing is to calculate the KPIs. That's the key performance indicator. And the first KPI we are calculating is the total orders. So we want to know the total order that were placed from January 2023 to June 2023. So to calculate the total order, what we need to do is to count the transaction ID that we have in our table, since each transaction ID represents an order and it is unique for each transaction. So we need to count the total transaction ID, and that will give us our total order. So we are going to assign our count to a variable called the total order, and we are counting our transaction ID. So we are using the method count. So this statement will count the transaction item, and the values that it returns will be saved in a variable called the total orders. So to see the results, we need to call out our variable, which is the total orders. So let's execute this statement. So from our results, we have that the total order placed was 149,116 orders. So the next KPI we want to calculate is the total sales. To calculate the total sales, we need to sum the transaction quantity. The transaction quantity contains the units that are being sold for each transaction. So for us to get the total sales that we have made in the first 6 months of 2023, then we need to sum our transaction quantity. So to do that, we will assign our value to a variable called the total sales, and we are summing our transaction quantity. So we use the method sum. So this statement will sum the transaction quantity and save the result inside a variable called the total sale. To view our results, we need to call that variable total sales. So let's execute it. So from our results, we can see that the total sale made was 214,470. So this is the total sales that we have made. So the next KPI we need to calculate is the number of working days. We want to find out how many working days are between our 1st January 2023 to our 30th June 2023. And to do that, we are going to subtract the minimum or the earliest date of transaction from our latest date of transaction. So let's assign our value to a variable called number of days. In this variable, we are going to store the difference between the latest transaction date, which we calculate using the max function, so minus earliest transaction date, which we calculate using the min function. So we are subtracting the minimum date of transaction from the maximum date of transaction, and the result will be a time delta. So in order to be able to return the number of days, we need to use the .day attribute. So we enclose this subtraction and then add the .days. So this attribute will return the result as a number. So to see our result, we need to call our variable number of days. Okay, so we have our results, which says that the total number of working days was 180 days. The next KPI is to calculate our average order per day. We want to find out the average order that we have placed from our 3 stores per day. So to do that, we are going to assign our result to a variable called average orders per day. So this variable is going to store the average order. And to calculate this average order, what we need to do is to divide our total order by the number of working days. So we have our total orders divided by number of days. So let's view our results by calling the variable average orders per day. So from our results, we can see that the average orders that were placed from our 3 stores was 828 orders. So we have the average order to be 828 orders per day. So the next KPI is to calculate our total revenue. We want to calculate the total revenue. And to do that, we need to sum our revenue column. So let's assign our result to a variable called total revenue, which is going to be the sum of the revenue column. So we are summing the revenue column using the method called sum. So to view our result, we call our variable that will store the result. I will have that the total revenue generated was $698,812. So here is our total revenue. The final KPI that we want to calculate is the average order value. That is, how much is a customer willing to pay on a visit. So to calculate the average order value, we need to divide our total revenue by the number of orders that were placed. So let's call it our AOV. So this will store our results, and our average order value will be the total revenue divided by total orders. So let's see our result by calling our variable. So from our result, we can see that the average order value is $4.06. So that means that a customer is willing to pay $4.06 on a visit from our 3 stores. So we have been able to calculate our KPIs. And in the next section, we are going to begin to perform an in-depth analysis. And the first analysis we are going to carry out is our order analysis. So the first order analysis we want to carry out is to calculate the total orders by transaction hour. We want to find out from this analysis what the peak hour order is. So we're going to group our total order by the transaction hours. So we will use the group by function to perform this. We want to group our data, so data.group by, and we are grouping by the column called the transaction hour. And we don't want this column to be our index, so we indicate it by using as index equal to false. So we are going to perform an aggregate. What we want to do is to count our transaction ID, which will give us the total order. So we are aggregating, and the result of this our aggregate will be called our total orders. So this total order will be equal to the column we are aggregating is our transaction ID, and the aggregate function we are using is the count. So this statement is going to group our table by the transaction hour, and then it's going to count the transaction ID and save the result inside a column, which it will call the total order. So let's execute this statement. So here is our result. We have our order by the transaction hours. So here is the transaction hours, and here are the total order. So this our result, we want to assign it to a variable called hourly orders. So to do that, we will assign it to a variable called hourly order. So this our variable hourly orders will store this our table. So to view our results, we need to call our variable the hourly orders. So we have our results to be the same. So the next thing we need to do is to plot these hourly orders. So to plot our data, first we need to define our axis. So figure axis to be equal to plt.subplots, and then we are specifying that the figure size should be equal to the width will be 10 and the height will be 3. We want to plot a bar chart, so that will be AS.bar. And for us to plot our bar chart, we need to indicate what will be our x-axis and what will be the height of our bar. So the x-axis will be equal to our hourly order, and the column that will be our x-axis will be our transaction hour. So this column, transaction hour, will be our x-axis, while this column, total order, will be the height of our bar. So we are specifying that our x-axis will be the transaction hour, and then we need to indicate the height. So the height will be equal to our hourly orders, and then the column will be the total orders. So let's plot this and see our bar first before we can format the chart. So here is our bar chart. So we can see our data has been plotted. We have the different transaction hours, and we have the total order plotted on the y-axis. So we need to format this our chart. If you look at this chart, we can see that not all the transaction hours are being indicated in this chart. This is because our transaction hour contain the data of the type integer. So we need to convert this column to text or string. And to do that, we can do that inside our charts by using the .asType method. So .asType, and we're indicating that this column will be a string. So this addition to our statement will convert this transaction hour to a string. So let's rerun this statement. So here is our data. We can see that all the transaction hour is now showing in our chart. So we need to format this chart. We need to remove this border, which is called the spine, and we need to remove the y-axis and add a chart title and x-axis label, and also add a data label on top of each of these bar. So we'll start by adding a chart title. So we want to add title. We do that by using the .set title method, and we're calling the chart the hourly orders. Next is to add the x-axis label. So we want to add the x-axis label. So we do that using the .set x label. Our x-axis contain our transaction hours. So next, we want to remove the spine. So remove spine. So we use the as.spines, and we need to specify the spines that we want to remove. So we want to remove the top spine, the right spine, and the left spine. So we set this spine, the visibility of this spine, to be equal to false. Okay, let's execute this statement first to see the format that we have added. We have an error. The error is on our visibility. So this is not supposed to be visibility. It's supposed to be visible. So we are setting the visibility, which is set visible, to false. We can see that in our chart, we have been able to remove the spines. The top right and left spine we have added our chart title and the X label. So we need to remove this y-axis and then add a data label. To remove the y-axis, so remove y-axis, that's what we want to do. So we have that our ax.y-axis, we are setting the visibility, set visible to be equal to false. So that has removed our y-axis. Okay, so the last thing that we need to do is to add a data label on top of these bars. So we want to add data label. So to add data label, we will use the annotation method. So first of all, we'll loop through our values. Our values is the total order. We want to loop this value and return the index of each of these value and the value. So that's what we want to do. So for index and values, in enumerate our total order is in our variable called the hourly orders. So we have our total orders. So this statement is going to loop through our total order and return the index and the values. Okay, so we want to annotate. So as dot annotate. And what do we want to annotate? We want to annotate our values and the position, that's the x and the y index, will be equal to the index and the values. Then we need to set the horizontal alignment to be center alignment and also the vertical alignment to also be center alignment. So let's execute this statement. So we have our values. We can see that our values are still not properly placed, so we need to move it up a little bit. So we'll come to our values and increase the values, the position by 500. So we can see that our values is now properly placed. So based on this chart, we can see that our peak order hour are between 8 a.m. in the morning to 10 a.m. in the morning. So but the major peak hour is at 10 o'clock a.m. So here is our peak hours. We can also include the time 7 a.m. to also be our peak hour. So there are 4 peak hours: 7 a.m., 8 a.m., 9 a.m., and 10 a.m. So next on our order analysis is we want to see the order by day of the week. So we want to calculate the orders by day of the week. We are going to group our data based on the day of the week and count the transaction ID to be our total order. So let's go. So we have our data dot group by, and we are grouping by, and we are grouping by the day of the week. Then also we are grouping by the day. So this will give us the integer for each day of the week, while this will return the name of those days of the week. And we don't want this to be the index, so we'll specify that index is equal to false. Then we are using our aggregates. We are performing an aggregate, and this aggregation will be called the total orders, which will be equal to, we are counting our transaction ID, and the aggregate function is count. So let's execute this statement. So here is our statement. We have the day of the week, that's the integer. We have the name of the days of the week, and then we have the total order. And from the results, we can see that the total orders appear to be the same for the different days of the week. So there is no more difference in the total orders based on the days of the week. Okay, so next we want to look at the total order by day of week and by the transaction hour. We want to see if there are days of the week and transaction hour where we have most of our orders. So we are going to group our data based on the day of the week and also based on our transaction hour. And to group our data, we're going to use the pivot table. So with pivot table, our index, that's our row, will be the day of the week, and then our columns will be the transaction hours. So to do that, we have our data dot pivot table, then our index is equal to the day of week, okay, then our columns will be equal to the transaction hour. Then we need to specify what will be the values. So our values will be the transaction ID, and then we need to specify the aggregate function that we want to perform on our values. So the aggfunc will be equal to count. So this our statement is creating a pivot table, and our index will be the day of the week. We are using the integer so that it can be sorted from Monday to Sunday. Then we have our columns to be the transaction hour, and the values that we are working on is our transaction ID, and the aggregate function we are using is count. So we want to count the transaction ID and group it by day of the week and transaction hour. So let's execute this statement. So we have an error. The error says that there is unexpected keyword called the columns. So we made a mistake in our columns. We did not add n. Okay, so let's rerun the statement. So here is our results. So we have the day of the week, where 0 indicates Monday and 6 indicates Sunday. And then we have the transaction hour, and here is our total order for each of the day of the week and the transaction hour. So we save this our result into a variable called the day hour order, so that we can be able to plot a heat map of our results. So we save it into a variable called day hour orders. Okay, so let's call the variable to be sure day hour orders. So we have successfully saved it inside this variable called day hour orders. So we need to plot a heat map of this our results. Okay, let's add a cell. So in this cell we are plotting a heat map of our results. So to do that, first we specify the figure axis to be equal to plt.subplots, and the figure size is equal to the width to be 10 and the height to be 4. Then to plot a heat map, we're going to use the Seaborn library. So sns.heatmap. We need to specify a data frame, which is the day hour orders. Next, we need to indicate the color we are going to use for the heat map. So we use the blues. So let's view our heat map. So here is our heat map. Here is the result of our heat map, and here is the color scale, which shows that the higher the value, the darker the blue color. With that, we can see that the transaction hour with the highest value are the hours between 8 to 10 a.m. in the morning. So what that means is that the hours of 8 a.m. to 10 a.m. have the highest number of transactions. That is where most of our transactions occur, the hours between 8 a.m. to 10 a.m. And when we check the days of the week, we can see that on Tuesday has the darker blue color, and also on Friday and Sunday. So that means that the days of the week where we have most sales are on Tuesday, on Friday, and on Sunday between the hours of 8 a.m. to 10 a.m. So next on our order analysis is the monthly orders. So we want to calculate the orders by month. So to do that, we need to group our data by the transaction month and then count the transaction ID as the total order. To do that, we need to group our data. So data.group by, and we are grouping by the transaction month and also by the transaction month name. So this return the month integer, while this return the month name. And then we don't want this to be the index, so we're stating that as index should be equal to false, and we are aggregating. So we are calling the column to be our total orders, and we are aggregating on the transaction ID, and we are counting each of these transaction ID. So the aggregate function is count. So this will group our data by the transaction month and the transaction month name and count the transaction ID as the total orders. So let's execute this statement. So here is our result. We have our transaction month, the transaction month name, and the total orders. So let's save this result inside a variable called the monthly orders. Okay, monthly orders. So we have saved this our result in this variable called the monthly orders. So we want to view the results by calling on the monthly orders. So that was executed successfully. So the next thing is to plot a bar chart of these monthly orders. So we're going to follow the same procedure that we took to plot this our hourly order. I'm going to copy the statement and paste it and then explain the statement. So here is our statement for plotting a bar chart of our monthly orders. Here we specify our figure axis, and we're saying that the figure size will be width of 5 and height of 3. And then we're plotting a bar chart. Our x-axis will be the transaction month name, and which we are extracting the first 3 letters using this method .str. So we are extracting the first 3 letters of the transaction month name, and then our height, or the height of our bar, will be the total orders. So this will be the height of our bar, and here will be, and this will be our x-axis. Okay, then this statement will remove the spine from our chart, while this will remove the y-axis. Then this will set the x-axis label to month, while this statement will add a chart title. Then finally, this statement is going to annotate our bar and give each bar a data label. So let's execute this statement. So here is our bar chart for the total orders by month. And we can see from the bar that the month with the highest order is the month of June, followed by the month of May, and then the month of April. Next on our order analysis is we want to calculate the total orders by the different stores. So to do that, we'll group our data by the store ID and then count the transaction ID as our total orders. So let's dive in. So our data dot group by, so we are grouping by the store ID, and also we group by the store location. So we want to see the location of each of those stores, and we don't want this to be our index. So as index is equal to false, then we are aggregating, we are calling that column to be our total orders, and the column that we are aggregating is our transaction ID column, and the aggregate function is count. So let's execute this statement. So from our result, we have the store ID, we have the store location, and then we have the total order. So our result is not sorted in descending order. So we want to sort this result by the total orders in descending order. So we'll go back to our statement and add our sort values, and we're sorting by the column total order. So we indicate the column that we are sorting by, which is total orders, and then we are sorting in descending order. So ascending is equal to false. We sort our data in descending order by the column called total orders. So let's execute this statement. So we have our result. Our result says that the store with ID of 8 located at the Hell's Kitchen has the highest order of 50,735 orders, followed by the store located at Astoria, and finally the store located at the Lower Manhattan. So next, we want to plot a pie chart of these total orders by the stores and see what percentage of the total order that we have from the different stores. To be able to plot a pie chart of our result, we need to save our result inside a variable. So we'll call it the store orders. So we are saving our table inside a variable called the store orders. So let's call that variable to make sure that it has been saved. So we have our store orders. Okay, so our variable, the store orders, contain our table, which we are going to use to plot a pie chart of the orders by the stores. So I'll copy the statement and paste it, and then we'll execute it together. So here is our statement for plotting a pie chart of the orders by the store. So here we define the figure axis. Then we are plotting a pie chart. So that's what we have here, AH.pie. And we are plotting the total orders. So this is what we are plotting, and we are indicating that we want the percentage of each of these total order, and our label will be the store location. So our label will be the store location. So, and we added a title, the percentage of orders by the store. So let's execute this statement. So we have our pie chart. We can see that the store at the Hell's Kitchen and Astoria both have the same percentage of total order, while the store at the Lower Manhattan has the percentage order to be 32%. Next, we want to see the orders by the product category. We want to see which product category have the highest order and which had the lowest order. So to do that, we need to group our data by the column called product category and then count our transaction ID as the total order. So that will give us data.group by. So we are grouping by the product category, and like we do before, we don't want this to be our index. So as index is equal to false, then we are aggregating. So we are calling the result of our aggregate to be the total orders. This will be equal to the column we are aggregating is our transaction ID, and we are counting the values in that column. So let's execute this statement. So here is our result. Our result is not yet sorted in descending order, so we need to sort our result. So sort values, and we are sorting by the column called the total orders, and we are sorting that column in descending order. So ascending will be equal to false. So let's execute it. So from our result, we can see that the product category with the highest order is coffee with a total of 58,416 orders, followed by another category called the tea, which had a total order of 45,449. And then the third in this result is the bakery, which had a total order of 22,796. And the product category with the lowest order is the packaged chocolate with a total order of 487. So this is the result of our order by the product category. So the final analysis in this order will be to find the top 10 products by order. So in this analysis, we are going to group our results by the product type and count the transaction ID to be our total order. So our data.group by, we are grouping by the product type, and we don't want this to be our index. So as index equal to false, then we are aggregating, calling that column to be our total orders to be equal to, so the column that we are aggregating is our transaction ID column, and we are counting. So if we execute this statement, we'll have the result of our products and the total order for each of the products. So we need to sort these results in descending order by the total order. So we sort our values. We are sorting by the column called the total orders, and we are doing that in a descending order. So we have sorted our results in by the total order in this descending order, and we can see that the product with the highest order is the brewed chai tea. So we need to return the top 10. Our interest is in the top 10 products. So we will use the head function dot head and then specify that we want the top 10. So with this, we will return the top 10 products by order. So here is the top 10 products by the total order. So the brewed chai tea leads with a total of 17,183 orders, followed by the gourmet brewed coffee and then the barista espresso, which ranked third by order. So our next analysis will focus on the revenue generated, and the first analysis will be the monthly revenue. So we want to calculate the revenue generated by month, and to do that we need to group our data by month and sum the revenue column. So we have our data dot group by, we are grouping by our transaction month, and also we are grouping by the transaction month name to return the name of the month, and we are specifying that this should not be our index. So as index equal to false, then we are aggregating. We are calling the result to be the total revenue, and the column that we are aggregating on is our revenue column, and the aggregate function we are using is the sum. So with this result, we are going to sum the revenue column and group it by the transaction month and the transaction month name. So let's execute this statement. So here is our result. So we have the transaction month, we have the transaction month name, and then we have the total revenue. And from our result, we can see that the month with the highest revenue is the month of June, followed by the month of May. So this can also be attributed by the total order. So when we calculated the total order by month, we discovered that the month with the highest order is the month of June. So if this month has the highest order, then we should expect this month to generate the most revenue. And that is what we can see from our results. The total revenue in the month of June appears to be the highest revenue. So next, we want to find the total revenue by the product category. We want to see which product category generates the most revenue. So we group our data by product category and sum the revenue. Okay, so our data dot group by, we are grouping by our product category, and we don't want this column to be our index. So as index equal to false, then we are aggregating, calling the result to be the total revenue, and we are aggregating on the column called the revenue, and the aggregate function is our sum. Okay, so let's execute this statement. So we have our result of the total revenue by the product category. Let's sort this result in descending order of total revenue. So in our statement, we are sorting the values, and we are sorting by the column called the total revenue, and we are doing that in descending order. So ascending equal to false. So from our results, we can see that the category with the highest revenue is the coffee category, with a total revenue of $269,952. So this category has the highest revenue, followed by the category called the tea category, and then the bakery. So let's go back to our order. So based on the order, the category with the highest order is the coffee category, and this coffee category appears to be the category with the highest revenue. Okay, so lastly, we want to find out the top 10 products by revenue. So we want to find out which of our products are generating the most revenue. So we are going to group our data by the product type and then sum our revenue. So we have our data dot group by, and we are grouping by the product type and we don't want this to be our index. So as index equal to false, then we are aggregating, calling the column to be our total revenue, and we're aggregating on the column called the revenue, and we are summing that column. Also, we want to sort our values by this total revenue column. So we're sorting by the total revenue, and we're doing that in descending order. And then finally, we're interested in the top 10 values. So with this statement, here is our result of the top 10 products by revenue. So these are the products that generate the most revenue. We have the first product to be the barista espresso, followed by the brewed chai tea and the hot chocolate. So this is how to carry out an exploratory data analysis using Python as the tool for analysis. So the final part of this analysis is data communication. And what we do here is we gather the insight that we have extracted from our data and present it to our client, which is the Marvin Roasters. So this can be done using our PowerPoint presentation. Also, we can create an interactive dashboard with Power BI or Tableau, which will enable our client to explore the insight by themselves and filter based on the different stores. So this brings us to the end of this lesson, and I hope you have learned something from this exploratory data analysis. So if you find this video to be helpful, please click on the like button and don't forget to subscribe to our YouTube channel so that we can keep you updated on our new videos.